Hi all, welcome to SK Data Diaries. Myself Sendhu Kumar, I'm working with MNC as a data engineer. In our previous video, we saw about three different layers in data engineering. In that, we discussed for a storage we are using data lake. Data lake is a cloud storage. In cloud service, there are three main players in the market: Microsoft Azure, Amazon AWS, and then Google GCP. In our upcoming videos, I'm going to use Microsoft Azure servers. You are free to explore the cloud service of your choice. Before the evaluation of cloud technology, we were using Hadoop distributed file system known as HDFS. Nowadays, industry is moving towards the cloud services. So I'm giving this HDFS part as a homer. When it comes to processing, we are going to use Azure Databricks. Databricks is nothing but commercial version of Apache Spark. You can imagine Apache Spark as a government school and Databricks as a private school. Here you have to pay extra premium for the additional services. What I'm trying to say is Apache Spark is the open source computing service. For accessing Databricks, we have to pay money to the service provider. Understanding Apache Spark and its internals make you stand out from the other data engineers. In our earlier video, we saw the difference between the monolithic system and distributed computing. Databricks and Apache Spark fundamentally use the core concept of distributed computing. Let us try to understand the architecture of Spark. Here, our driver program receives the job, analyze it, and create the logical execution plan. Then it's split into stages according to the data dependencies. Then assign the task to the executor for the parallel execution. Again, a textbook explanation. I will give you the analogy. We'll come back to the same definition. In that time, you can understand this concept better. Imagine a restaurant. This entire Spark architecture is a workspace where your food is being prepared. You imagine this driver program as a head chef. Cluster manager is your kitchen manager. You imagine this worker node as the kitchen setup inside our workspace. Now we are getting the order for egg curry. Our HF is receiving the order and analyzing and find that there is two main component in making egg curry. One is boiled egg, another one is making curry. He split the process and give the task of making boiled egg to kitchen number 1 and give the process of making curry to kitchen 2. Here both the kitchen starting their work independently. But note that kitchen 2 have to wait to receive the boiled egg from kitchen 1. This process of transferring the dish from kitchen 1 to kitchen 2 is known as the shuffling. You note that there is a dish movement happening here. Once it receives the boiled egg from the kitchen 1, it finish the order and give it back to our head chef. Now we will see another example. In a scenario 2, we are getting the order for idli and dosa. Our head chef receiving the order and analyzing there are two components in the order. So he split the order, give the idli making process to the kitchen number 1 and dosa making process to kitchen number 2. Here you can see there is no dependency between the kitchen 1 and 2. Once the kitchen 1 finish the process of making dish, it will give it back to our head chef. The same goes to kitchen 2. Keep this entire analogy in your mind and try to understand what is job, stage and task in Spark architecture. Job is the top level unit of execution triggered by a single action. In our case, head chef receiving the order for dishes is the action which triggers this entire job of making the dish. Just keep in mind, count, collect, write, and save is the action which creates the job. Application can consist of multiple jobs. In our example, our head chef can take multiple orders in the same time. We will talk about this DAG diagram in our upcoming video. Whenever the shuffle boundary is there, that will create the stages. In our case, we saw that there is a dependency between the kitchen 1 and 2 when making the egg curry. So that kind of a transformation known as the Y transformation their data movement needs to be happen. This creates the stage. Group by key, join, reduce by key, repartition. These are the example for Y transformation. When there is no dependency between the two worker nodes, then those transformation known as the narrow transformation. Map, filter, with column, these are the example for narrow transformation. Here there is no data movement happening in between the executor. Task is the smallest unit of work that happen in Spark. We imagine that this is the kitchen 1 and this is kitchen 2. You can see inside the kitchen 1 we are having two associate chefs. Work of this associate chefs is known as task. In this video, what we understood is every action triggers the job. Each white transformation inside the job creates the new stages. Each stage have multiple tasks. In upcoming video, we will see this with the example so that you can understand better the architecture of Spark, and we will cover what is DAG. With that note, I'm ending today's video. I hope I added some value. Don't forget to subscribe the channel and press the bell icon. Keep learning. Happy learning. Thank you.